let's sketch another graph of a linear inequality, only let's make it a little more complex this time. Let's do x minus y is less than 2. Now we're going to approach this in the same way that we would an equation. We're going to solve this linear inequality for y. So we're going to subtract x from this side of the inequality, and we'll subtract it from this side. So we're going to have a minus y is less than 2 minus x. I'm going to get rid of this minus here by dividing everything by a minus 1. So that's going to make this y, and I'm going to divide through by minus 1 and convert the inequality side to an equal sign. This will give me the boundary of the inequality graph. By making this an equal, I'll get the boundary of the inequality graph. So divide through them by minus 1, make this an equal, so that this would be a positive x and a minus 2. Now I can build a little table for my x and y and find the equation of the line that's the boundary on the inequality. So if x equals 0, y equals a minus 2. If x equals 2, y would equal 0. 2 minus 2 is 0. If x is 4, we'd have 4 minus 2 is 2. Y would equal 2. Try a negative number, a minus 2, we'd have a minus 2. Minus 2 would be a minus 4. Now let's go ahead and graph that line. Find some graph paper here. So we'll draw our coordinate system. And I'll mark every little grid here equal a half a unit. So this would be 1, this would be 2, 3. This, of course, is my y axis. This is my x. We have to label our axis. And this would be a 1, 2, 3, 4, and 5. Whoops, I can't even add today. I can't even number a graph today. This would be 1, 2, 3, 4, and 5. And then on our negative on the y would be a negative 1, negative 2, minus 3, minus 4, minus 5, and the same on the x up here. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. Now, we've established the boundary of the inequality as a line with this equation. There's a couple ways we could graph this. I suppose I could have done this by the slope method here, the slope-intercept method, which we just learned about, and probably, or I did, as I did it, I built this table of x and y, and I'll do it that way because I started it that way, but that's the long way to do it, remember. So we have x is 0, y is a minus 2, x is 2, y was 0, x was 4, y was 2, x is a minus 2, y is 4. So 0 and a minus 2 in the y would be right here. 2, x equals 2 right here, and y equals 0. That would be a point on this line. X equals 4, here's 4. Y equals 2, that would be up here, 1, 2. And the last one, x equals a minus 2, y equals, this would be a minus 4. I didn't put the sign in there. Y equals a minus 4 would be down here. So this is the boundary line for that inequality. Now the question is the inequality on this side of the boundary line or is it on this side of the boundary line? Which side is it on? One way to do that is just go ahead and rewrite your inequality, which was x minus y is less than 2, and plug in a point over here and see if that point is a valid point for that inequality. We could plug in this point, which is 0, 0, or this point, which is 0, 1, or this point, which is a minus 1, 0. It doesn't matter. Plug in any point. Let's plug in 0, 0, this point here. So x would be 0 minus 0. Is that less than 2? Well, this is 0. Is that less than 2? Yes, this is less than 2. So our inequality is on this side of the line. So the inequality is any point on this side of the line. Okay? So that was pretty easy. And that's the end of that problem.